Picture this. You're standing on a beach, looking at a grain of sand. That single grain barely visible between your fingers represents Earth. Now look at the entire beach stretching for miles in both directions. That's not even close to the scale of our solar system. We're about to take a journey that will humble you, terrify you, and make you question why we ever thought we were the center of anything. A journey across 4 billion miles of cosmic real estate, from the sun's scorching embrace to the frozen darkness where our solar system bleeds into interstellar space. This isn't a gentle tour. We're going to encounter a planet where it rains sulfuric acid, and the atmospheric pressure would crush submarine moons with more water than Earth, hiding alien oceans beneath miles of ice. A storm larger than our entire planet has been raging for over 400 years, and a region so vast and dark that our fastest spacecraft will take 30,000 years to cross it. We're traveling at the speed of light, 186,000 miles per second, fast enough to circle Earth 7 times in 1 second. And even at that impossible speed, this journey will take us over 10 hours to complete. 10 hours at light speed, just to reach the edge of our cosmic neighborhood. By the time we're done, you'll understand why every space mission ever launched has been hilariously ambitious, why we've barely scratched the surface of exploration, and why the universe doesn't care about your Monday morning problems. So strap in. Leave your existential comfort at the door. And whatever you do, don't look back, because by the time we turn around, Earth will be an invisible speck, one pale blue dot among 8 billion trillion stars, utterly insignificant and absolutely everything at the same time. Let's find out what's really out there. We begin at the only place that matters, the sun, that bright thing you've been ignoring your entire life, except for beach days and Instagram sunsets. The sun is not what you think it is. It's not a ball of fire. Fire requires oxygen, and space has none. The sun is actually a continuous thermonuclear explosion, fusing 600 million tons of hydrogen into helium every single second, releasing energy equivalent to 100 billion nuclear bombs detonating simultaneously, every single second. And it's been doing this for 4.6 billion years. The sun contains 99.86% of all mass in the solar system. Jupiter, Saturn, Earth, everything else were all just rounding errors. Cosmic pocket change orbiting a fusion reactor that could fit 1.3 million Earths inside its volume. The surface temperature? A comfortable 10,000 degrees Fahrenheit. But that's nothing compared to the core 27 million degrees Fahrenheit. Hot enough that atoms literally cannot exist in recognizable form. It's just a soup of charged particles moving at speeds that would make the Autobahn look like a parking lot. Here's the terrifying part. Every second, the sun loses 4 million tons of mass just from converting matter to energy via E equals mc. 4 million tons gone, transformed into the light that lets you scroll through TikTok. And we're about to leave its warm embrace and venture into the cold darkness beyond. At light speed, it takes us 8 minutes and 20 seconds to travel the 93 million miles from the sun to Earth. So when you look at the sun, do not actually look at it. You're re-seeing it as it was 8 minutes ago. The sun could explode right now, and we'd get 8 more minutes of blissful ignorance before the wave of radiation ended everything. Sleep tight. First stop, Mercury, the solar system's forgotten stepchild. The planet nobody talks about because it's boring, right? Wrong. Mercury is a hellscape that makes Death Valley look like a spa resort. Daytime temperature, 800 degrees Fahrenheit. Hot enough to melt lead, zinc, and your spacecraft if you're not careful. But wait for nightfall, because Mercury barely has an atmosphere to hold heat, and temperatures plummet to minus 290 degrees Fahrenheit. That's a temperature swing of over 1,000 degrees. Imagine walking outside, and it's hot enough to bake a pizza. Then 6 hours later, it's colder than liquid nitrogen. Mercury doesn't do moderation. The planet is also shrinking. Its iron core is cooling and contracting, causing the surface to wrinkle like a raisin. These wrinkles, called lobate scarps, are cliffs up to a mile high and hundreds of miles long. The entire planet has geological shrink wrap. Oh, and one more thing. A day on Mercury lasts 59 Earth days. But a year one orbit around the Sun takes only 88 Earth days. Do the math. 2 Mercury days equal 3 Mercury years. Time is broken here. NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, discovered ice in permanently shadowed craters at the poles. Ice on a planet where the equator is hot enough to melt metal, because the universe has a sense of irony. Mercury is small, barely larger than our moon, but it's dense. 70% iron core. If we could mine it, we'd have enough iron to build, well, everything. The problem? It's so close to the Sun that getting there, landing, mining, and leaving would require more energy than most countries produce in a year. So Mercury remains what it's always been, a scorched, airless ball of metal and rock that serves as a reminder that proximity to power comes with consequences. Let's keep moving. Next up, Venus, named after the Roman goddess of love and beauty. The brightest object in our night sky after the moon. Ancient poets wrote sonnets about its elegance. Venus wants to kill you in the most creative ways possible. Let me paint you a picture of romance. Surface temperature of 900 degrees Fahrenheit. Atmospheric pressure 92 times greater than Earth equivalent to being 3,000 feet underwater. An atmosphere made of 96% carbon dioxide with clouds of sulfuric acid that rain down but evaporate before reaching the surface. This is what runaway greenhouse effect looks like. Venus wasn't always like this. Billions of years ago, it might have had oceans, liquid water, maybe even conditions suitable for life. But something went catastrophically wrong. The greenhouse effect spiraled out of control, the oceans boiled away, and Venus became a cautionary tale about climate change written in planetary scale. The Soviet Union's Venera program sent multiple landers to Venus in the 1970s and 80s. Longest any survived was 127 minutes before being crushed, melted, and corroded. The images they sent back, the only photos we have from Venus' surface, show a hellish landscape of volcanic rock under a sickly orange sky. Venus rotates backwards compared to most planets. It spins clockwise, while nearly everything else in the solar system spins counterclockwise. Scientists think a massive collision early in its history knocked it into retrograde rotation. Venus literally got hit so hard it spins the wrong way. And here's the really weird part. Venus rotates so slowly that one full rotation takes 243 Earth days. But one Venus year one orbit around the Sun takes only 225 Earth days. A Venus day is longer than a Venus year. Let that sink in. Oh, and the winds? At the cloud tops, winds scream around the planet at 250 miles per hour, circling Venus in just 4 Earth days. Superrotation. The atmosphere moves 60 times faster than the planet itself. Scientists still don't fully understand why. Venus is what happens when a planet goes wrong. It's Earth's twin in size and mass, but it took a left turn into hell somewhere along the way. A reminder that planetary habitability is fragile, temperamental, and apparently quite easy to lose forever. Some scientists think we could terraform Venus by building massive solar shades to cool it down over centuries. Others suggest floating cities in the upper atmosphere where temperatures and pressures are actually Earth-like. But right now, Venus is untouchable. Beautiful from a distance, lethal up close. The solar system's toxic ex-girlfriend. Let's get out of here before the acid clouds give us ideas. Home, Earth, the pale blue dot, the only known harbor of life in an ocean of cosmic indifference. We're not going to spend much time here because you already know Earth. You live on it. You complain about it. You take it completely for granted. But let's get some perspective. Earth sits in the habitable zone, the Goldilocks region where it's not too hot, not too cold. Liquid water exists. A magnetosphere generated by our molten iron core deflects deadly solar radiation. An atmosphere thick enough to breathe, but not thick enough to crush us. Plate tectonics that recycle carbon and regulate temperature over geological timescales. The odds of all these factors aligning? Astronomical, literally. We've discovered over 5,000 exoplanets in other star systems. Maybe a few dozen could potentially harbor life. Maybe, out of billions of planets in our galaxy alone. Earth isn't special because it's the center of the universe. It's special because it's a statistical anomaly. A cosmic accident that happened to work out in biology's favor. And we're slowly cooking it with fossil fuels, but that's a different documentary. The point is, as we travel outward, keep Earth in mind. Because everything from here on out is hostile, frozen, radiation-soaked, or all three at once. Mars, the red planet. Humanity's obsession. Elon Musk's retirement plan. Mars is what Earth might have become if everything went slightly wrong. It's about half Earth's diameter, with 1/10 the mass. It used to have a thick atmosphere, flowing rivers, maybe even oceans. Billions of years ago, Mars was wet and warm. Then its magnetic field died. We're not entirely sure why, and solar wind stripped away most of its atmosphere over millions of years. Now, Mars is a frozen desert with an atmosphere so thin it's basically a vacuum. Surface pressure is less than 1% of Earth's. Unbreathable, even if it wasn't 95% carbon dioxide. Average temperature, minus 80 degrees Fahrenheit, though it can hit 70 degrees at the equator in summer. We've sent more missions to Mars than any other planet. Orbiters, landers, rovers. We've driven robots across its surface for years, analyzing rocks, drilling into ancient lake beds, searching for any hint that life once existed. And we've found ambiguous results. Methane spikes that could be geological or biological. Organic molecules that could be contamination or indigenous. Seasonal changes in atmospheric composition that don't quite make sense. Mars is the ultimate cosmic tease. Here's what we do know. Beneath the surface, there's water ice. Lots of it. The Phoenix lander dug it up in 2008. The Mars Reconnaissance Orbiter spotted massive glaciers buried under dust. There's enough water on Mars to cover the entire planet in an ocean 100 feet deep. But it's frozen, locked in permafrost and polar ice caps. To live on Mars, we'd have to thaw it, terraform it, and somehow restart its dead magnetic field to keep solar wind from stripping away any new atmosphere we create. That's a multi-thousand-year project, assuming we don't extinct ourselves first. Elon Musk wants to put 1 million people on Mars by 2050. That is ambitious considering we can barely keep astronauts alive on the International Space Station for 6 months without their bones deteriorating and their eyeballs deforming. Mars is humanity's backup drive. The planet we'll flee to when we've thoroughly trashed Earth. Except it's a backup drive that doesn't work properly, has no atmosphere, and is 140 million miles away at its closest approach. But hey, the Martian sunsets are blue. That's something. 2 tiny moons orbit Mars, Phobos and Deimos, named after the Greek gods of fear and dread. Fitting. Phobos orbits so close and so fast that it rises in the west and sets in the east twice a day. It is also slowly spiraling toward Mars and will either crash into the planet or break apart into a ring system in about 50 million years. Even Mars's moons are doomed. Let's keep moving. The asteroid belt awaits. Pop quiz. What does the asteroid belt look like? If you said, a dense field of tumbling rocks requiring expert piloting to navigate, congratulations, you've watched too much Star Wars. The reality is far more boring and far more terrifying. The asteroid belt sits between Mars and Jupiter, spanning roughly 1 astronomical unit. That's 93 million miles. It contains millions of asteroids, from pebbles to dwarf planets. The largest, Ceres, is 600 miles in diameter and classified as a dwarf planet because it is big enough that gravity has crushed it into a sphere. Total mass of the entire asteroid belt? About 3% of the Moon. That's it. All those millions of rocks combined wouldn't even make a decent moon. And they're spread over such a vast area that if you flew through the asteroid belt blindfolded, your odds of hitting anything larger than a grain of dust are essentially zero. NASA's flown multiple spacecraft through it without even trying to avoid anything. The asteroid belt is 99.99999% empty space. So why does it exist? Why didn't these rocks coalesce into a planet? Jupiter. Jupiter's immense gravity more on that monster later stirred up the region so violently that asteroids could never settle down enough to merge. Every time two rocks got close to forming something bigger, Jupiter's gravity would fling them apart or send them careening into the sun or out of the solar system entirely. The asteroid belt is essentially a failed planet, a planetary graveyard, rocky debris that will orbit the sun for billions of years, never achieving the destiny of becoming a world. But here's where it gets interesting. Some asteroids are worth more than Earth's entire economy. 16 Psyche, for example, a metallic asteroid about 140 miles across, made almost entirely of iron and nickel, with traces of gold, platinum, and other precious metals. For context, the entire global economy is worth about $100 trillion. Psyche alone is worth 100 times more than every stock market, every bank account, every asset on Earth combined. NASA is sending a spacecraft to Psyche right now. Launch happened in 2023, arrival in 2029. Not to mine it, just to study it. Because Psyche might be the exposed core of a protoplanet that got its outer layer stripped away in a cosmic collision. A peak inside planetary formation. But make no mistake, when asteroid mining becomes economically viable, and it will, there will be wars over these rocks. Actually, scratch that. There already are wars. Legal wars. The U.S. passed the SPACE Act in 2015, granting American companies the right to own and sell resources extracted from asteroids. Luxembourg passed similar laws. So did Japan and the UAE. Who owns space? Legally, nobody. Practically, whoever gets there first with the biggest guns and lawyers. The asteroid belt also poses an existential threat, not from the belt itself, but from asteroids that escape it. Near-Earth asteroids, rocks whose orbits bring them uncomfortably close to us, number in the tens of thousands. We've cataloged about 30,000 of them. Maybe another 10,000 remain undiscovered. Any asteroid over 140 meters in diameter is classified as potentially hazardous if it comes within 4.6 million miles of Earth. That sounds like a lot, but in space terms, it's a cosmic hair's breadth. It struck the Yucatan Peninsula 66 million years ago, releasing energy equivalent to 100 trillion tons of TNT. The impact vaporized itself, excavated a crater 110 miles wide, triggered magnitude 10 earthquakes, spawned tsunamis a mile high, and threw so much dust into the atmosphere that the sun disappeared for years. Global temperatures dropped. Photosynthesis stopped. Food chains collapsed. 75% of all species went extinct. And here's the fun part. The dinosaur killer is considered a small to medium-sized impact. The late heavy bombardment 4 billion years ago rained down asteroids hundreds of miles across. Impacts so large they remelted Earth's crust and boiled the oceans. We live in a cosmic shooting gallery. The bullets are invisible until they're already here. And our defense plan as of 2022 is NASA's DART mission, which successfully redirected a small asteroid by crashing a spacecraft into it at 14,000 miles per hour. We moved it, barely, by a fraction of a percent. That's our planetary defense. Kinetic impactors, literally just hitting asteroids with spacecraft and hoping they change course enough. Sleep tight, humanity. Beyond the asteroid belt, things get weird, and big, and terrifying in ways that make Venus look like a minor inconvenience. Jupiter is next, the king of planets. And it's so massive, so strange, so utterly alien that it might as well be a solar system unto itself. At light speed, we've now traveled 45 minutes from the Sun. We've crossed 484 million miles. And ahead of us, impossibly large, even from millions of miles away, is Jupiter. Let me give you some numbers that won't mean anything until I contextualize them. Jupiter's mass, 318 times Earth's mass. Its volume, 1,321 times Earth's volume. You could fit every planet in the solar system inside Jupiter with room left over. It's 11 times wider than Earth. Storms on Jupiter are larger than our entire planet. And it's made of gas, hydrogen and helium mostly. Jupiter has no solid surface. If you tried to land on it, you'd just keep falling through increasingly dense gas until the pressure crushed your spacecraft into atomic components. About 1,000 miles down, the pressure becomes so intense that hydrogen stops acting like a gas and becomes a liquid. Keep going, and it becomes metallic hydrogen compressed so hard that electrons flow freely, making it electrically conductive like metal. We've never created metallic hydrogen on Earth for more than microseconds. Jupiter has an entire ocean of it, thousands of miles deep. At the core, if Jupiter even has a core, pressures reach 100 million times. Earth, its atmospheric pressure and temperatures hit 50,000 degrees Fahrenheit. That's hotter than the Sun's surface. Jupiter is what happens when a planet almost becomes a star, but doesn't quite make it. To ignite fusion, it would need to be about 80 times more massive. So it's a failed star, a substellar object, a cosmic what-if. But don't tell Jupiter it's a failure, because it dominates this solar system like a gravitational tyrant. Jupiter's gravity is so strong that it affects everything. It flings comets out of the solar system. It deflects asteroids that would otherwise hit Earth. Some scientists call Jupiter our protector without it. Asteroid impacts on Earth would be far more frequent. Other scientists disagree, arguing Jupiter also sends asteroids toward Earth by stirring up the asteroid belt. Either way, Jupiter's gravity shapes the entire outer solar system. And then there's the Great Red Spot. You've seen the pictures. That massive red storm on Jupiter's face. It's been there since at least 1831, possibly for 400 years or more. It's a high-pressure anticyclonic storm, basically a hurricane that rotates in the opposite direction of Earth hurricanes. How big? It used to be 3 times Earth's diameter. It's shrunk recently, probably temporarily, to only 1.3 times Earth's diameter. Only, this storm is larger than our planet and has been raging continuously for longer than the United States has existed. Wind speeds, 400 miles per hour at the edges. Nobody knows what fuels it. There's no landmass to disrupt it, no friction to slow it down. Just endless gas and energy from Jupiter's interior heat. Jupiter radiates more heat than it receives from the Sun. It's actually shrinking, very slowly converting gravitational potential energy into heat as it contracts. Jupiter is glowing in infrared wavelengths, warm to the touch if you could somehow touch a gas giant. And we haven't even talked about the moons. Jupiter has 95 confirmed moons. Most are captured asteroids, tiny irregular rocks. But 4 moons, the Galilean moons, discovered by Galileo in 1610, are worlds unto themselves. Io, the most volcanically active body in the solar system. Over 400 active volcanoes erupting continuously, spewing sulfur into space. The surface is constantly repaved. Nothing Io looks like today will look the same a million years from now. Tidal forces from Jupiter literally squeeze and flex Io like a stress ball, generating internal heat that keeps the volcanism going. Europa, an ice-covered moon with a subsurface ocean containing more water than all of Earth's oceans combined. The ice shell is 10 to 15 miles thick. Beneath it, a liquid water ocean 40 to 100 miles deep, kept warm by tidal heating. Europa might harbor life. Microbial life, sure, but life. NASA's Europa Clipper mission, launching in 2024, will investigate Ganymede, the largest moon in the solar system, bigger than Mercury, the only moon with its own magnetic field. A layered interior with a possible subsurface ocean sandwiched between layers of ice. Could also harbor life, though it's less promising than Europa. Callisto, the most heavily cratered object in the solar system. Ancient, geologically dead. But beneath the cratered ice, another possible ocean. Because apparently every Jovian moon has secrets. Jupiter is less a planet and more a miniature solar system. It has its own weather, its own moons, its own gravitational dominance. Standing on Europa, if you could stand there without dying, Jupiter would dominate the sky. 25 times larger than our moon appears from Earth, swirling with storms and lightning. And Jupiter is just the first gas giant. Saturn is next, the jewel of the solar system. We've now been traveling at light speed for 79 minutes. We're 886 million miles from the Sun, and ahead of us is the most photogenic planet in the solar system, Saturn. Everyone knows Saturn. It's the planet with rings, the one that makes every other planet jealous. But here's what most people don't know. Those rings are temporary. The rings are made of billions of chunks of water ice, ranging from grain of sand size to house-sized boulders. They're bright because ice reflects sunlight beautifully. They're thin, some parts are only 30 feet thick, despite being 175,000 miles across. And they're young. Maybe 100 million years old, maybe less. Saturn is 4.5 billion years old. The rings are cosmically speaking brand new, possibly formed when a moon or comet wandered too close and got torn apart by Saturn's cis-tidal forces. We caught Saturn during its jewelry-wearing phase, and the rings are dying. They're raining down onto Saturn at a rate of about 6,000 pounds per second, pulled in by gravity. At this rate, they'll be gone in 100 million years. We're living at the exact moment in cosmic history when Saturn has rings. 1 billion years ago, no rings. 1 billion years from now, no rings. We lucked out. Saturn itself is similar to Jupiter, a gas giant, mostly hydrogen and helium, no solid surface. But Saturn is less dense. So much less dense that if you could find an ocean big enough, Saturn would float. A planet that floats. Saturn's atmosphere features hexagonal storms at the poles. Not circular, hexagonal, a 6-sided jet stream pattern that's been stable for decades. Each side of the hexagon is 8,600 miles long. The entire hexagon could fit 4 Earths inside it. Nobody fully understands why it's hexagonal. Fluid dynamics simulations can replicate it, but the mechanism in Saturn's atmosphere remains mysterious. Saturn also has 146 confirmed moons. The most famous is Titan. Titan is the second largest moon in the solar system. It's bigger than Mercury, and it has something no other moon has, a thick atmosphere. Titan's atmosphere is mostly nitrogen, like Earth's, but 50% denser. Surface pressure on Titan is 1.5 times Earth's, meaning you could walk around on Titan without a pressure suit. You still need oxygen, and a heated suit surface temperature is minus 290 degrees Fahrenheit, but you would explode or suffocate instantly. Progress. Titan has lakes. Liquid lakes. Not water, the water is frozen rock hard. These are lakes of liquid methane and ethane. Hydrocarbon lakes. Oil lakes, essentially. Titan has more liquid hydrocarbons on its surface than Earth has oil reserves. There's a methane cycle on Titan, analogous to Earth's water cycle. Methane rain, methane rivers, methane evaporation, methane clouds. Cassini spacecraft images show what look like river deltas and drainage networks carved by flowing methane. Titan might be the most Earth-like place in the solar system, if you squint, and ignore the part where everything is made of frozen petrochemicals, and the temperature would instantly freeze your lungs solid. Some scientists think Titan could harbor exotic life forms based on liquid methane instead of liquid water. Life as we don't know it. Probably not, but possibly. NASA and ESA are planning a mission called Dragonfly, a nuclear-powered quadra-drone that will fly around Titan taking samples. Launch date, 2027. Arrival, 2034. Because nothing in space happens quickly. Another of Saturn's moons, Enceladus, is even more intriguing. It's tiny, only 300 miles across, but it has geysers. Jets of water vapor and ice grains shooting 500 miles into space from cracks in its south polar region. Cassini flew through these plumes and detected salts, organic molecules, and silica. Evidence of hydrothermal activity on the ocean floor. Hot water vents, like the ones on Earth, where life might have originated. Enceladus has a global subsurface ocean. Small moon, massive implications. It checks every box for habitability. Liquid water, energy source, organic chemistry. If life exists in our solar system beyond Earth, Enceladus is a top contender. But we're not stopping there. 2 more gas giants await. The ice giants. The forgotten outer worlds. At light speed, we're now 2 hours and 40 minutes from the Sun. We've crossed 1.8 billion miles. Welcome to Uranus, the butt of every middle school joke and the solar system's most tilted planet. Uranus is tilted 98 degrees. It rotates on its side. Its poles point roughly where most planets' equators point. Something probably a massive collision during the solar system's chaotic youth hit. Uranus so hard knocked the entire planet sideways, and it stayed that way. This means Uranus has the most extreme seasons in the solar system. Each pole gets 42 years of continuous sunlight, followed by 42 years of continuous darkness, as Uranus completes its 84-year orbit around the Sun. Imagine 4 decades of day, then 4 decades of night. Uranus is an ice giant, not a gas giant. It's made mostly of water, methane, and ammonia ices surrounding a small rocky core. The methane in its atmosphere absorbs red light, making Uranus appear cyan blue. It's beautiful in a cold, distant, indifferent sort of way. Uranus radiates very little heat. Jupiter and Saturn glow warm in infrared. Uranus is just cold, minus 370 degrees Fahrenheit in the upper atmosphere. The coldest planetary atmosphere in the solar system. Why so cold? We don't know. Maybe the impact that tilted it also disrupted its internal heat. Maybe its internal structure is different. Uranus keeps its secrets. We've only visited once. Voyager 2 flew by in 1986, giving us our only close-up images. Everything we know about Uranus comes from that single encounter and decades of telescope observations. Uranus has 27 moons, all named after characters from Shakespeare and Alexander Pope. Miranda, one of the smaller moons, might be the strangest. Its surface looks like a planetary jigsaw puzzle, with mismatched terrain suggesting it was shattered and reassembled by its own gravity. Uranus also has rings, but they're dark and thin. You wouldn't notice them unless you were looking carefully. Even the planet's rings are underwhelming. Uranus is the forgotten middle child of the solar system. Too far to visit easily, too bland to attract attention. But it's still a planet, a world 4 times wider than Earth, with 14.5 tons Earth's mass, spinning sideways through the void. Respect the tilt, at least. We're 4 hours and 10 minutes from the Sun at light speed, nearly 2.8 billion miles out. The Sun is now just a very bright star, providing 900 times less light than Earth receives. Neptune, the last true planet, the final giant. Neptune is Uranus's twin, similar size, similar composition, similar blue color. But unlike Uranus, Neptune radiates significant internal heat. It puts out 2.6 times more energy than it receives from the sun. Where does this energy come from? We're not certain. Possibly leftover heat from formation. Possibly gravitational contraction. Possibly precipitation of diamonds deep in its atmosphere. Yes, diamonds. Neptune's pressure and temperature conditions might create diamond rain. Carbon in the atmosphere, compressed under extreme conditions, forming diamonds that fall toward the core like hailstones made of jewelry. We can't confirm this, obviously, but laboratory experiments suggest it's possible. Neptune might have a layer of liquid diamond ocean. Neptune has the fastest winds in the solar system. Supersonic winds reaching 1,200 miles per hour at the equator, faster than the speed of sound. On a planet that receives almost no energy from the sun. How? How does a planet so far from any obvious energy source generate winds twice as fast as Jupiter has? Mystery. Neptune doesn't play by our rules. Neptune's most famous feature, the Great Dark Spot, was a storm system similar to Jupiter's Great Red Spot. Voyager 2 observed it in 1989. By 1994, Hubble looked again, and the spot was gone. Storms on Neptune form, rage for years, then disappear. The atmosphere is chaotic, turbulent, violent. Neptune has 16 known moons. The largest, Triton, is geologically active, despite being 200 degrees Fahrenheit below freezing. Triton has geysers that erupt nitrogen gas 5 miles high. It has a thin atmosphere. It reflects 70% of the sunlight that hits it, one of the most reflective objects in the solar system. And Triton orbits backwards. Retrograde, the only large moon in the solar system that orbits opposite to its planet's rotation. Why? Because Triton isn't originally Neptune's moon. It's a captured Kuiper belt object, a dwarf planet that wandered too close and got gravitationally snagged. Neptune stole it, and now tidal forces are slowly pulling Triton inward. In a few 100 million years, it'll cross the Roche limit, the distance at which tidal forces overcome gravity, and Triton will be torn apart, forming rings around Neptune far more spectacular than Saturn's current jewelry. But we won't be around to see it. Neptune is the last true planet, the edge of the classical solar system. Beyond Neptune, it's not empty far from it, but it's no longer the realm of planets. It's the realm of exiles, dwarfs, frozen relics, the Kuiper belt and beyond. Let's address the elephant in the room, or rather, the dwarf in the belt, Pluto, discovered in 1930 by Clyde Tombaugh, declared the 9th planet, beloved by schoolchildren memorizing planetary mnemonics for 76 years. Then, in 2006, the International Astronomical Union changed the rules. They defined planet more rigorously, and Pluto failed the test. Specifically, Pluto failed Criterion 3, has cleared the neighborhood around its orbit. Pluto shares its orbital region with thousands of other objects. It's the largest member of the Kuiper belt, sure, but it hasn't gravitationally dominated its zone. Demoted, reclassified, dwarf planet, the internet lost its mind. Justice for Pluto. People wore T-shirts. Scientists received death threats, as if Pluto cared about human taxonomical categories. But here's the thing. Visiting Pluto made us fall in love all over again. NASA's New Horizons spacecraft flew by Pluto in July 2015 after a 9.5-year journey. The images it sent back stunned everyone. Pluto is not a boring ice ball. It has a heart-shaped glacier of frozen nitrogen. It has mountains made of water ice as hard as rock at those temperatures, rising 11,000 feet. It has a thin atmosphere that freezes and falls to the surface as snow during Pluto's winter. Pluto has weather, seasons, geology. It's a world, small but complex. Pluto's largest moon, Charon, is so big half Pluto's diameter that they orbit a common center of gravity in space between them. It's less a planet-moon system and more a binary dwarf planet system. Charon is tidally locked to Pluto, and Pluto is tidally locked to Charon. They always show each other the same face. Two cosmic dancers, frozen in eternal eye contact. Pluto is 3.6 billion miles from the Sun. At that distance, the Sun looks like a bright star. Daylight on Pluto is equivalent to twilight on Earth. Cold, dim, and lonely. Surface temperature, minus 375 degrees Fahrenheit. Nitrogen ice, methane ice, water ice harder than granite. 1 year on Pluto lasts 248 Earth years. Pluto hasn't completed a full orbit since its discovery. It won't return to where Clyde Tombaugh first spotted it until 2178. Pluto's orbit is eccentric and tilted. Sometimes it crosses inside Neptune's orbit, making it temporarily closer to the Sun than Neptune, though they'll never collide due to orbital resonance. Pluto is weird. It doesn't fit neat categories. It's too small to be a planet, too complex to dismiss. A reminder that the universe doesn't care about our need for tidy classifications. And Pluto is just one of thousands of objects in the Kuiper belt. The Kuiper belt stretches from Neptune's orbit at 30 astronomical units out to roughly 50 astronomical units. 1. O astronomical unit is the distance from Earth to the Sun, about 93 million miles. So the Kuiper belt begins 2.8 billion miles out and extends to 4.6 billion miles. It contains hundreds of thousands of icy bodies, larger than 60 miles across, and trillions of smaller objects. Leftover debris from the solar system's formation 4.6 billion years ago. The bits and pieces that never coalesced into planets. Many objects here, Plutinos, dwarf planets, and asteroids, in 2 to 3 orbital resonance with Neptune, meaning they complete 2 orbits for every 3 Neptune orbits. Gravitational choreography that keeps them stable. Other notable residents, Eris, slightly smaller than Pluto, but more massive. So massive its discovery in 2005 triggered the whole "what is a planet" debate that demoted Pluto. Eris's moon, Dysnomia, is named after the daughter of the Greek goddess Eris. Dysnomia is the goddess of lawlessness. Astronomers have a sense of humor. Makemake, named after the creation deity of the Rapa Nui people of Easter Island. Roughly 2/3 Pluto's size. Red-brown surface, possibly covered in methane and ethane. Haumea, shaped like an egg. Rotates once every 4 hours, so fast it's stretched into an ellipsoid. Has 2 moons and a ring system. Probably the result of a massive collision that turned it into a cosmic football. Arakoth, the farthest object ever visited by a spacecraft. New Horizons flew by it in 2019. It looks like a snow's 2 lobes gently merged together. A pristine relic from the solar system's birth, barely changed in 4.6 billion years. These objects tell us what the early solar system looked like. They're time capsules, frozen archives of planetary formation. They're also the source of short-period comets. Sometimes a Kuiper belt object's orbit gets perturbed by Neptune's gravity, sending it careening toward the inner solar system. As it approaches the Sun, ice sublimates, creating the classic comet tail. Comets are Kuiper belt refugees fleeing toward the Sun. But the Kuiper belt isn't the edge, not even close. Beyond the Kuiper belt is the scattered disk, where objects have highly elliptical orbits flung there by gravitational encounters with Neptune. And beyond that, well, things get strange. At 76 astronomical units from the Sun's 7 billion miles, we find Sedna. Sedna is a mystery, wrapped in ice, wrapped in an orbit that makes no sense. Sedna's orbit is ridiculously elliptical. At its closest, it's 76 astronomical units from the Sun. At its farthest aphelion, it's 937 astronomical units away. It takes 11,400 years to complete one orbit. Think about that. Sedna was last at perihelion around 9,400 BCE, when humans were just figuring out agriculture. It won't return until 4000 CE, and here's the problem. Sedna's perihelion is too far for Neptune to have scattered it there. Neptune's influence doesn't reach that far. So how did Sedna get into such a weird orbit? Theories. A passing star disrupted it billions of years ago. A massive unseen planet in the outer solar system nudged it. The hypothetical Planet 9. The Sun had a binary companion star. Early on, it was ejected, scattering objects like Sedna in the process. We don't know. Sedna's orbit is gravitationally unexplainable given known solar system objects. And Sedna isn't alone. We found other distant objects with similarly strange orbits. 2012 VP, 2010 GB174, others. Their orbits cluster in ways that suggest something massive is influencing them. Enter Planet 9. In 2016, astronomers Konstantin Bedogin and Mike Brown proposed that a planet 5 to 10 times Earth's mass orbits the Sun at distances between 400 and 800 astronomical units. Its gravitational influence would explain the clustering of distant object orbits. Planet 9 would take 10,000 to 20,000 years to orbit the Sun. It would be cold, dark, and nearly impossible to spot with current telescopes. If it exists, the evidence is circumstantial orbital clustering statistical anomalies, but compelling enough that multiple observatories are actively searching. Imagine a true ninth planet lurking in the darkness, 10 times Earth's mass, 4 times farther from the Sun than Neptune, undiscovered because it's so faint and moves so slowly against the background stars. Or imagine it doesn't exist, and we're seeing patterns in orbital data that are just statistical noise. Either way, the outer solar system is full of surprises. And we're still not at the edge. Beyond Sedna, beyond even the hypothetical Planet 9, lies the Oort Cloud, the true edge of the solar system. We're now 10 light hours from the Sun, nearly 7 billion miles. The Sun is a bright point of light, indistinguishable from other bright stars, except that it's slightly brighter. And we're still in the solar system. The Oort Cloud is a theoretical spherical shell of icy objects surrounding the solar system. It begins around 2000 AU to 186 billion miles and extends to possibly 100,000 astronomical units. That's 9 trillion miles, nearly 2 light years. The nearest star, Proxima Centauri, is 4.24 light years away. The Oort Cloud reaches halfway there. It contains trillions of objects, possibly more mass than Jupiter's worth, scattered across a volume so immense it defies comprehension. These are dormant comets, frozen ice balls that have been in deep freeze since the solar system's formation. We've never directly observed an Oort Cloud object. We've inferred its existence from long-period comets with orbital periods over 200 years that come from random directions rather than the ecliptic plane where planets orbit. Halley's Comet, with its 76-year orbit, is a short-period comet from the Kuiper belt. But Hale-Bopp, with its 2,533-year orbit, comes from the Oort Cloud. Comet Hyakutake, 70,000-year orbit. Oort Cloud. Something perturbs these objects, maybe a passing star, maybe galactic tides, and they fall toward the Sun, taking thousands or millions of years to complete one orbit. Some fall all the way in, swing around the Sun in spectacular fashion, and either shoot back out for another multi-millennium orbit or get ejected from the solar system entirely. We are surrounded by a cloud of frozen comets so vast that light takes nearly 2 years to cross it. The Oort Cloud is where the Sun's gravity weakens to almost nothing, where the solar system blurs into interstellar space, where inside and outside stop having clear meaning. It's the solar system's halo, its ghost, its forgotten boundary. And only 5 human-made objects have ever reached this far. Voyager 1 and Voyager 2 launched in 1977. Designed to explore Jupiter and Saturn, they exceeded every expectation. Voyager 2 became the only spacecraft to visit Uranus and Neptune. Voyager 1, after its Saturn flyby, was flung upward out of the ecliptic plane on a trajectory toward interstellar space. Both are still functioning, still sending data. 47 years later, Voyager 1 is now 15 billion miles from Earth, 159 astronomical units. Voyager 2 is 12.5 billion miles, 132 astronomical units. Signals from Voyager 1 take 22 hours to reach Earth traveling at light speed. We send a command, wait 22 hours for it to arrive, wait another 22 hours for confirmation. 44-hour round-trip communication with a spacecraft the size of a small car running on 1970s technology powered by decaying plutonium. In 2012, Voyager 1 crossed the heliopause, the boundary where the solar wind from the sun gives way to the interstellar medium. It's officially in interstellar space. Voyager 2 crossed in 2018. Both are still technically in the solar system. They won't reach the Oort Cloud for another 300 years and won't fully exit it for 30,000 years. 30,000 years. By then, humanity will either be extinct, have transcended to something unrecognizable, or spread across the galaxy. And the Voyagers will still be coasting through the darkness, inert and silent, carrying golden records with sounds and images from Earth. Messages in bottles thrown into an ocean so vast that the odds of anyone finding them are infinitesimal. But we sent them anyway, because we're human, and we have to try. Pioneer 10 and 11, launched in the early 1970s, are also headed outward. Pioneer 10's last signal was received in 2003. It's now 130 astronomical units out, silent and alone. Pioneer 11 went silent in 1995. And New Horizons, the spacecraft that visited Pluto, is now 58 astronomical units from the Sun, racing outward at 31,000 miles per hour. It has enough power to operate until the 2030s, possibly beyond. 5 spacecraft, humanity's farthest flung creations, ambassadors to a void that doesn't care and will never respond. So we've reached the edge, the boundary between our solar system and the space between stars. What's out there? Mostly nothing. Interstellar space is a near-perfect vacuum, about 1 atom per cubic centimeter. For comparison, Earth's atmosphere at sea level contains about 10 molecules per cubic centimeter. Space is 10 quintillion times emptier than air. But mostly nothing doesn't mean nothing. There's gas hydrogen, helium. There's dust tiny grains of carbon and silicon. There's radiation cosmic rays, light from distant stars, the cosmic microwave background radiation left over from the Big Bang. The galaxy rotates. Stars orbit the galactic center, including our Sun, at 514,000 miles per hour. We complete one galactic orbit every 230 million years. The last time we were in this part of the galaxy, dinosaurs hadn't evolved yet, and the galaxy is full of stars. 400 billion stars in the Milky Way. Most have planets. Trillions of planets in our galaxy alone. And there are 2 trillion galaxies in the observable universe. The numbers stop meaning anything. They're too big. We can say them, but we can't comprehend them. Our solar system, this vast expanse we've been traversing for 65 minutes at light speed, is a single grain of sand on all the beaches of Earth, and Earth's beaches are only 1 galaxy among trillions. We are not the center of the universe. We are not even a noticeable feature. We are an infinitesimal detail in a cosmos so large that our brains literally cannot process its scale, and yet, we're here. On that pale blue dot, 93 million miles from a star, in a solar system 287 billion miles across, in a galaxy 100,000 light-years wide, in a universe 93 billion light-years across. We exist. We built machines that crossed our solar system. We sent messages to aliens that probably don't exist. We look up at the night sky and ask questions. That matters. Maybe not to the universe, but to us. So let's bring it back. We started at the Sun, a thermonuclear explosion that's been detonating for 4.6 billion years. We passed planets where it rains acid, storms rage for centuries, and oceans hide beneath miles of ice. We crossed asteroid belts, dodged debris fields, gazed at rings made of diamonds and ice. We visited moons more interesting than planets, dwarf planets with hearts made of nitrogen, and comets frozen in time since the solar system's birth. We traveled 287 billion miles at the speed of light, and it took us 65 minutes. And now you understand. You understand why every space mission is a miracle. Why landing on Mars is harder than people think. Why we've barely scratched the surface of exploration. The solar system is incomprehensibly vast, and it's tiny compared to interstellar space. And interstellar space is tiny compared to the galaxy. And the galaxy is tiny compared to the universe. But here's what I want you to remember. Every atom in your body was forged in stars that exploded billions of years ago. The calcium in your bones, the iron in your blood, the oxygen you're breathing, all created in stellar furnaces and scattered across space. You are made of star stuff. You are a way for the cosmos to know itself. And somewhere out there on Europa's subsurface ocean, on Enceladus's hydrothermal vents, on an exoplanet orbiting a distant star, there might be other beings asking the same questions we're asking. Or we're alone, the only witnesses to the universe's vast, indifferent beauty. Either way, the answer is staggering. So look up tonight. Find Jupiter if it's visible. See Saturn's rings through a telescope. Remember that you're re-standing on a planet orbiting a star in a galaxy full of stars, in a universe full of galaxies. Remember how small you are. And remember how extraordinary it is that something as small as you can contemplate something as large as this. That's the real miracle. The universe doesn't care about you, but you can care about the universe. And in a cosmos governed by entropy and indifference, caring might be the most rebellious act possible. Thanks for joining me on this journey to the edge of the solar system. I'm humbled. I'm terrified. And I am grateful to live in a time when we can send machines to the edge of everything and bring back the truth. The truth is, we're impossibly small and impossibly lucky. Remember that next time you complain about Monday. Until next time, keep looking up.